Hello everyone! In this video, I'm going to go over another example of how to use the DSolve function, this time with a derivative that represents a spring mass damper system. So the derivative that we are going to use is going to be 12x double dot plus 53x dot plus 96 equals 0. And our initial conditions are going to be dx of 0 equals 0.001 and x of 0 equals 0.005. Now, just like before, we are going to use a time interval. In this case, we are going to have it go from 0 to 600 seconds, and we are going to have a increment of 0.5. This is going to give us a lot of data points, but it's going to help with our accuracy tremendously. Now, all that's left to do is to add our DSolve. Again, we're going to say x equals DSolve. And we're going to first put in our equation. 12 times x double dot, which is written as capital D squared at x, lowercase x, plus, again, another set of parentheses, 53 times capital D x plus 96 equals 0. And next we're going to add our initial conditions. So the first one is going to be dx of 0 equals 0.001. And the second condition is going to be x of 0 equals 0.005. And then the last thing we specify is our time interval t. And now, with all of that solved, we're going to run it. And as you can see here, we get a solution. Now, if we wanted to graph this, all you need to do is copy the solution, which can be found by going into the variable, in this case x. And once you copy it, you can then make a new variable, say x data equals, and then I would take out the spaces. But otherwise, it will calculate the data points for you. And now, if we were to plot the data points, we get a function. In this case, that looks like this. So that is another example of using the built-in DSolve function in Matlab. The DSolve function is a very useful function that can be used if you install the symbolic math toolbox.